We saw fruitful research outcome in the areas of environmental change on land and seas in the Arctic, and now we would want to also aspire to expand our scope of geological research as well into Greenland. Crisis always comes with an opportunity, and in order to change such threat into an opportunity, insights are necessary. We need to read the present and changes in the Arctic, and today we would like to introduce you to the importance of Korea's Arctic research as well as research domains that feed into such insights. I truly hope this year's newly established seminar on Korea Arctic research projects bring in new energy into Korea's activities in the Arctic. Thank you.
Thank you. And next, we have President Kim Ung-seo of KIOST for congratulatory remarks.
Good day, distinguished guests, ladies and gentlemen. I am Kim Ung-seo, President of KIOST, or Korea Institute of Ocean Science and Technology. I would like to extend my gratitude to President Do Ki of Korea Maritime and Ocean University, here to congratulate the opening of the seminar, as well as President Kang Song-ho and particularly Vice President Shin Young-chul here on behalf of Dr. Kang Song-ho of KOPRI. And my sincere thanks also go to the experts participating today as speakers and panelists. Thank you very much for joining us. Out of our distinguished guests here today, I also see some familiar faces, and I'm very happy to meet you in person. In addition, I would like to thank the experts from government institutions, including Ministry of Oceans and Fisheries and research institutes, joining the seminar online. This year, COVID-19 changed the world. Almost every bit of our lives is being impacted, and KIOST is, of course, no exception. The scope of our field research activities have been reduced and some cancelled, making it very challenging to conduct any research at all. And we are seeing a transition into an untapped online platform for various international conferences as well as internal meetings. Today's event, in line with the government's quarantine measures in response to COVID-19, only the speakers and the panelists are here with us offline, and the majority of the audience are joining us online. Amid such difficult times, KOPRI is hosting this seminar on Korea Arctic research projects as part of Arctic Partnership Week 2020 to review the current status of Arctic research conducted up till now and to open up a promising future for scientific studies in the Arctic. And I would like to extend my words of encouragement and congratulations regarding such endeavor. The Arctic is located at the tip of the Northern Hemisphere, and it may seem irrelevant to us. However, the impact reaches Korea as well, and due to global warming, all the eyes and ears of the world are now focused on the region. For example, the environmental changes in the Arctic climate are directly impacting the occurrences of extreme weather events and natural disasters in Korea. And sea ice decline offers promising prospects for Korea on utilizing the Northern Sea route. Thus, the importance of the Arctic is ever increasing. 4 million people live in the circumpolar north, and changes in the environment are a big threat to these residents. Therefore, it is important to solve the challenges of the inhabitants as well as the pending issues of Korea through scientific research. In that aspect, The diverse research topics to be covered at the seminar, including monitoring research in the Arctic, meteorological and climate impact of the Arctic and Korea, research on the Arctic's pathogenic microorganisms in response to diseases emerging from the Arctic, and research on fossils from the Arctic's paleoenvironment deserves the interest of not only the researchers in the academia, but also the average citizen. I truly hope the seminar serves as a meaningful venue where presentations by the researchers of COPRI and discussions led by experts enable us to review scientific issues in the Arctic and usher in a future for the Arctic through scientific research. Thank you very much.
Thank you very much. And next, I would like to invite President Odaki of Korea Maritime and Ocean University for congratulatory remarks.
Good morning, ladies and gentlemen. Actually, I was invited by the president of the COPRI a couple of days ago to give congratulatory remarks for this seminar. Actually, I was planning to speak in Korean, but I myself thought it is very important for us to consider the importance of the polar, especially in North Pole Arctic problems. So I decided to speak in English directly to those who are attending via online and offline. So please understand my thought giving a speech in English. Good morning, ladies and gentlemen. I'm very honored to give these congratulatory remarks for opening the seminar on Korean Arctic Research Project. First of all, I would like to give a sincere thanks to the president of KIOST, Korea Institute of Ocean Science Technology, Ung-seo Kim, and Dr. Sung-ho Kang, the president of Korea Polar Research Institute, and to those who gave their strong support for this seminar, and to those who related to the Minister of Ocean and Fisheries. I'm standing here to emphasize the importance of the Arctic than ever before. As we had already known, the Arctic is melting down due to the global warming. Population growth is leading to increase in energy demand. It is expected to increase by 2 billion over the next 100 years. If nothing is made, the North Pole is likely to continue to be melting down. Today, this is not a place to stop population growth, but to discuss about the importance of the polar, especially Arctic. So this seminar should be focused not only on making good news of the Arctic warming, but also making slow the Arctic warming. COVID-19 is the result of destruction by humans on the Earth's natural environments. Infinity competition among human beings has created supplier-oriented economic system, and I believe that a supplier-oriented economic system had led to the infinitive development of natural resources. As a result, I think It caused a change in the microscopic world, which is difficult to predict by breaking the global environments, especially balances of global environments. I wonder if the change in the microscopic world directly related to a coronavirus outbreak. When the Arctic melted down, there are few reports that new microbes or microorganics emerged from the ground that were buried in the Ice Age. According to several reports, there may be beneficial microorganisms and there may be emergence of new viruses that are very fatal to human beings. In preparation for such a situation, fatal situation, taking various studies based upon various scenarios is very important for future generations. In this regard, I think today's seminar is very meaningful and important than ever, and I'm looking forward to seeing more practical and further progress through this seminar today. And I wish all success of all experts and participants attending at this seminar. Thank you very much.
President Kim Ung-seo and President Ho Duk-hee, thank you very much for your kind words. And next, I would like to walk you through today's event. All the current status and expected outcomes of the research currently ongoing at COPRI will be presented from 9:40 to 10 a.m. Vice President Shin Young-chun will give a keynote speech, and from 10 to 11:30, we have 6 research project presentations. And then we'll take a 10-minute break, and from 11:40 to 12:30, we will have a general discussion. Simultaneous interpretation is provided. Please use your interpretation receiver. And for online viewers, if you go to the official website of the 2020 Arctic Partnership Week, you may choose the language you wish to listen to and watch the seminar online. And now we will begin the keynote speech on the Korea's Arctic science from an accidental adventure to a planned voyage. Vice President Shin Hyung-chul of COPRI will give a keynote presentation.
Hello, everyone. I am once again on the podium after my opening remarks, and I really wanted to avoid the situation of having myself come up on the stage again, but I do ask for your understanding. The opening remarks were, of course, on behalf of President Kang Song of COPRI, but if I may add some additional comments, I want to say that Arctic scientific research is no longer just an area for COPRI. It's an area of research for Korea as well as the international community. Therefore, the 20 minutes I have right now, of course, will not be enough to go through an in-depth review of our current projects and also on what we have to do going forward. But I would like to hit on some of the key points. The topic or the theme, the title of my presentation is Korea's Arctic Science from an Accidental Adventure to a Planned Journey. So let me just brief you on what I want to talk about. It's true that COPRI was leading Arctic research up till now. So yes, I will be giving an overview on the research projects up till now. But then I also want to talk about what's in store for the future. And then I will conclude with some takeaway points. This is Dr. Kim Ji-young. It would be probably hard to identify him. But Arctic science, what we're doing in these various regions, if you think that it's about taking science to a freezing cold area, well, of course, that will not be doing the research justice. I think we need to define Arctic science, but I want to say that right now we're seeing sea ice decline. We're seeing it getting thinner. It's not only about the decline. Compared to 1979, you can see that there was a major decline, and we're seeing a downward spiral. Not only that, the thickness is also decreasing. It's getting thinner. And we all do know that it's becoming more accessible, and that is, of course, the reason why we're engaging in Arctic research. But Arctic, whatever happens in the Arctic does not stay in the Arctic, and Dr. Kim has extensively mentioned that in his presentation yesterday. Here, the cold fronts should remain in the Arctic, but due to the weakened air curtains, we're seeing the cold spells moving down to the southern areas. So why do we need to research the Arctic? This is an area where the Pacific and the Atlantic meets, and everything is changing so rapidly in the Arctic, and that is why we need to research this region right now. Not only that, we do see a coexistence of old traditions and new traditions, and old and new technologies. So it's where we need to learn from one another. And it's, of course, the case for all sciences, but it's important to make sure that we lend a serious ear to the inhabitants or the community. COPRI, as you're very well aware, is a government-sponsored research institution, and we've been blessed with their financing. We have our research icebreaking vessel and the station in Svalbard. Not only that, we have many expedition groups as well as sites. We have about 20 Arctic expedition groups per year, which consist of around 150 persons. And another point that I would like to emphasize is that more than 30%, 33%, come from the outside Korean research community as well as international communities. Of course, I indicated us as a mid-sized agency, but I want to say that once again, Korea is not a small country when it comes to Arctic research. In terms of our scope of participation, and considering the resources that we utilize, Korea's Arctic research is no longer just a COPRI project. In 1999, for the first time, Korean scientists, of course it was a Chinese boat or ship, but went to the Arctic. And what's interesting was that this was also the first attempt of China exploring the Arctic. It was 1999, so think of it. Right after the end of the Cold War, people started to go and explore the Arctic, and you can see that we weren't that much of a laggard. Afterwards, we got on the ships of Russia, and we started to engage in these expeditions. And as I've mentioned, in 1999, the first Korean scientists sailed to the Arctic waters, and Dasan Arctic Station opened in 2002. And in 2009, the ice-breaking research vessel Araon was commissioned, and it opened up a new frontier for Korea. Now we do have our own transport means. It's not getting on another flagship. Not only that, we were able to become an official observer of the Arctic Council in 2013. I believe that this is an important milestone when it comes to Korea's Arctic research. So the research on land, on the waters, and modeling, of course, I'm not sure whether this is the right way to classify, but if we do take that classification, we can say that up till now we've been on our ships to the Pacific waters and we've been engaging in multidisciplinary research. Not only that, many international initiatives were also something that we were taking part in, and we were trying to align our work with these initiatives. In addition to that, equipment, facilities, and also to offer more scientists on board, we've been engaging in international collaboration. It's the same case for the Antarctic, but for the Arctic, it's true that we are currently working in the Pacific waters. And if you think of the time spent to move to the Arctic waters, it's basically only 30 days to actually engage in research in earnest, and that is why we want to build another research vessel. Most of the research on land have to do with the atmosphere. It has to do with the atmospheric and terrestrial ecological studies, especially focused on greenhouse gases. And I did briefly talk about the polar vortex, where because Arctic, it's getting warmer and the cold front or the cold air mass is moving, and we're trying to predict and forecast the movement. And I think that this was a critical aspect of our research and also in our international collaboration. Professor Kim Beng-min mentioned that what happens in the Arctic does not stay in the Arctic, but I wanted to change stay to stop. It does not stop in the Arctic. We can also say that what happens outside the Arctic can end up in the Arctic as well. So once again, this is a two-way, bi-directional interaction. We cannot just say that the Arctic impacts us. We also may impact the other way. And this was also a part of the research topic with Professor Kim. This, I think, is a summary or Arctic science of COPRI in a nutshell. Climate gas dynamics studied with ecosystem responses in a range of physical and geographical settings is probably a good summary. It could be the waters, it could be the permafrost. And in addition, geologically and biologically speaking, what was the evolution in the Arctic? Understanding the history and understanding the mystery is also a key part of research. And last but not least is about observing Arctic as is and engaging in simulations and modeling to forecast and predict. Our Arctic science research can be summarized in these three areas. And in addition to that, this is not, of course, done only by COPRI, but considering the demands of the industry, we wanted to understand the sea ice and also the satellite and the cross-sectional research. We think that that can be utilized to open up new routes. But of course, we do not have some clear substance right now, but I think that seeds have been sown already to go down that direction. And there are also microplastics as one risk area. And we've started this research recently, and this was also our attempt to ride the tide of research trends around the world. So once again, why does the Arctic matter so much for Korea? I have to once again iterate that we are impacted by the changes in the north. And when we do research, well, the fact that we are engaging in such research makes it global, and it also contributes to making us a responsible member of the global community. And this may not come as reality right the next day, but we really need to be diligent in preparing for our next generation. We also need to understand other economic opportunities or business opportunities, and we really need to prepare in advance so that the next generation can benefit. So then, what kind of policies are in place to support this research? If you can see here, there is scientific research is key, and there are major goals in place. This plan of Korea indicates the scientific research arm. Of course, it may not be upfront, but I do want to mention that it is a very important part of Korean government policy. So key points to Korea's Arctic plan. Arctic is quite close for Korea. Antarctic is a frontier. However, Arctic is like our backyard. In other words, it has greater impact and it's quite close, closer than it seems. We want to be a pioneer and we also want to be a partner. It's very difficult to satisfy both ambitions, but Korea does have this ambition. And whatever the case may be, science and technology will be and will remain as a key element in this process. And partnership. Partnership is not as much a strategy, but more of a core value, and we really want to reap some joint fruit in the process of forging partnerships. In 1999, the first Korean scientist explored the Arctic, and it's been 20 years. There were 2 scientists at the time, and there are about 10 people that went to the Arctic in the 5 years time frame. But right now we have 100 to 200 persons going to explore the Arctic, which is a 15 times, 20 times increase. The Svalbard station and in the Barents Sea, we have we had a small ship of the Russian Meteorological Agency, was something that we had to rely on, but now we can go to many sites. So what kinds of areas do we research in earnest? We've been focused on geology and biology, but now we're engaging in comprehensive research. But I want to say that here it says comprehensive and exceedingly or excessively diverse. Some may think that we don't have focus. Some may be skeptical as to our focus and direction. And funding, of course, you can see that, this has led to more research projects. But of course, citizens, there are investors, so they would ask, what were the fruit? What were the benefits? What can you bring from research? I think that this is a question that can be posed by the Korean citizens. So whatever the case may be, what we wanted to pursue was, because we were scientists, we want to write good papers, and we, of course, wanted to engage in high-quality Arctic science. This is something that we really did pursue, and we are pursuing right now. But in addition to that, we want to continue on with monitoring long-term observations. So once again, something that we've been doing all along. And if you look at our research plans, it also indicates the pragmatic aspects, what kind of societal value it delivers. So whatever the method may be, these 3 aspects are something that have been in pursuit in our Arctic science. But what do we have to do better in the future? We, of course, explore many sites. However, even if we do understand the gas emissions of a particular site, if we do not have the big picture, this will be meaningless. How can we fill the gap would be the next question. We really need to have that pan-Arctic perspective, and without that perspective, at the end of the day, we will get frustrated, and it will just end as a very trivial arm of science, which will be quite unfortunate. And second is global connections, whether it be migratory birds or whether it be meteorological or climate survey or whether it be on microplastics. Arctic and the rest of the world is connected, and we really need to understand that in depth. And if we cannot define that, then I think we're not doing the science justice. So we need to make sure to focus on this going forward. And lastly, here it says novel, exciting discovery. We have Dr. Park here today as well. But what I want to say is that there are areas where it was unacceptable or unimaginable. But if we can really engage in some exciting discoveries, and if we can also find a pragmatic value to it, that would be great. So having this in mind in research is also something that we really need to excel. At the end of the day, whether it be big science or whether it be faithful baseline research, we want to do that. And we, of course, always indicate in our plans that it's useful. And if you may ask, what's useless research? Maybe contributing to the governance of the Arctic and the outcome. Maybe we can make an impact. Or maybe in terms of delineation, we may be able to expand our territories or not. It could be used as a guidance. Or we may be able to identify resource deposits or also create new products that will enable new economic value. But I think that we need something in between. big science and baseline science cannot just connect to these, well, three outputs, and we need something in between to connect the two. So what would that be? I believe that we do need translational research, and we need a mapping research. So if we research A and B, we need to understand how that's intertwined. We need to connect that together. We need to translate that, and we need to map that out. And if we cannot do that, Arctic research will not have a bright future. So small success stories and grand design. So I put this grand design versus small success stories, but this may seem different, but we need both. Dr. Seo talked about Japan's Arctic research. Japan has a grand title, Arctic Challenges for Sustainability, and it may seem trivial. It may seem like Korea and Japan, they're basically more or less the same. But what I want to say is Japan, I'm not sure about the number of papers that they have or citations, but they do have a design, they have a structure. But unfortunately, I think we do not have a robust system or structure in place. Japan and the relevant ministries have a big budget and it's supporting this effort. But we, of course, we have KMI and we have MSIT and we also have our own projects at COPRI. But I want to say that from the very beginning, if we have a systematic approach or a structure in place, that would be great. So we don't have that right now, but I think it's high time that we should be doing that right now, starting from today. And the small success stories, the small steps along the way will accumulate, and this will become very powerful. So whether it be a grand design or whether it be the small success stories, I think both are necessary. This is quoted from Dr. Lee's paper, Dr. Lee's book, The Melting Arctic, a boom and bloom for everyone? This is a question posed. So once again, the melting Arctic, a boom and bloom for everyone? Is that the case? Of course, with the melting Arctic, it's not just springtime for us. It could be very risky, and particularly during the winter season and moving on to the springtime, that's when it's the most dangerous. However, if we are faithful with Arctic research, we can take these risks, but it can be calculated risk that we will be taking. And when the opportunity comes, we can be smarter and we can find a safer way to take advantage of these opportunities in the longer run. At the end of the day, we are seeing a warming Arctic and we're seeing a fastly changing Arctic. And when we think of it with a nature's point of view or societal point of view, it is an experiment worth striving for. This was a picture I found on the internet. And so what is this? Whatever you do, you cannot do it alone. And if you look at this picture, it's quite interesting. Inside the North Pole, there's a toilet. I believe that this was a temporary toilet at this ice camp. So when you want to go to the toilet, you cannot do this alone in the Arctic. Once again, it's all about collaboration, whether it be collaboration within or whether it be with the international community. Collaboration, cooperation is a key value, a key strategy, and a core value. And with that, let me end my presentation. Thank you very much.
Thank you, Vice President Shin, for your presentation. And now we will move right on to the 6 presentations. We originally planned 15 minutes each to each presenter, but since we are slightly running behind schedule, and sometimes the presenters can get carried away, so please be mindful of time. And you have 15 minutes. And please be aware that we are running late. So I would like to present the first presenter on the topic Future Projections for Arctic Ocean Warming and Ecosystem Response. We have Dr. Yang Eun-jin. Good day. I am Yang Eun-jin from Kopri. I would like to present the research projects done by Korea in the Arctic Ocean, which is at the center of climate change. As you're well aware, the Arctic is currently at a huge crisis, which is why we focus on the Arctic. The Arctic in the past 50 years has been warming faster than the rest of the world. It is warming up very, very quickly. And the faster the Arctic warms, since the 1970s, sea ice cover has been quickly retreating. And in the summer, in the past 40 years, 75% of the sea ice has disappeared. And not only that, the sea ice is growing thinner and also younger because multi-year ice have all been gone. And so scientists believe that despite the uncertainties, by 2040 or by 2080, the Arctic will no longer have any white ice-covered ocean. If the Arctic Ocean is free of ice, in the high seas, unregulated fishing may happen. So, including Korea, 10 Arctic and non-Arctic states came together and signed the CAO fishing ban agreement in 2018. So, in the next 16 years following ratification, only scientific survey will be allowed in the CAO. Because of Arctic warming and the sea ice retreat, serious impact will be done onto the marine ecosystem. Fish resources in the northern hemisphere are moving upwards and they are losing habitat. And we have seen in 2012 that these fish resources that live in the cold waters have already moved upwards in the Arctic. And our beloved ingredient for fish and chips, the Arctic cod, in 30 years may disappear altogether from the Arctic Ocean. And since the 1980s, we have seen that the primary producer phytoplanktons have increased because as the sea ice melts, open water increases in the Arctic Ocean. And overall in the Arctic Ocean, in the Barents, Chukchi, and East Siberian seas, we see a higher concentration of phytoplanktons. And such rapidly changing Arctic Ocean in mind, what kind of research has been ongoing and will take place in the future by Kopri? The Arctic, there are Atlantic and Pacific Arctic. The Pacific Arctic is surrounded by Russia and the US, where the warm water comes through the Bering Sea and has been warming up. On the other side, the Atlantic water also flows through the coasts and enters here. In this area of the sea, it also connects to the Arctic routes and is geopolitically and geologically important. So in this water, Kopri looked at the changes in the water mass characteristics and the water flows and how they may connect to the warming. So we installed various equipment and looked at the marine dynamics. Since 2012, when Araon was built, in the Chukchi Sea, Bering Strait, Northeastern Siberian Sea, we have conducted focal research. And since 2012, we have conducted a comprehensive research. Korean research waters are strongly impacted by Pacific waters and recently has been seeing growing evidence of a warming trend driven by impact from Atlantic waters. Port Zaisak, or the water flowing in from Russia, this area of the sea is exposed to complex dynamical changes. And Atlantification, which is a new conceptual model, has been presented for these waters, and many scientists have been focused on the Atlantification of the East Siberian Sea. And in the next step of our project, we will be looking at the East Siberian Sea, which is a hotspot in the Arctic Ocean. So this is the target study area, the Chukchi Sea. Out of the entire Arctic Ocean, this is where the fastest warming is taking place. And since the 1980s, the ocean has been warming here, leading it is a leading hotspot for global warming in the Arctic Ocean. And according to recent research, warm Atlantic water is increasing overall in the Arctic Ocean. So the Atlantic water is considered a major factor for the warming of the Arctic Ocean. But as you can see here, in the Chukchi Sea and Eastern Siberian Sea, this has not been reported so far. So our research in the Arctic Ocean is supported by the Ministry of Oceans and Fisheries as an R&D project. And in the past 5 years, the Korea Arctic Ocean Observing System, or KAOS, was the phase 1 project. And as the second phase of KIOS, we have K-Aware, Korea Arctic Warming Research. K-Aware will be based on KAOS and based on the know-hows and trials and errors of KAOS. K-Aware will focus on the Siberian and Chukchi Seas and to examine how the reducing sea ice in the Arctic impacts the marine ecosystem and eventually will produce the scenarios of the future. We have these 9 research questions to focus on the retreating sea ice in examining physical changes and biogeochemical changes and ecosystem responses through analysis and modeling. On the field, we will be using the Araon and also look into the sea floor to install marine monitoring equipment. And we will also conduct research on the ocean and sea ice interaction. So looking at the sea ice changes and the ocean changes, we will look at what overall impact there is on the marine ecosystem. This is the KAOS field equipment installations and other field work done. K-Aware project will look at the temperature increase, freshening, and acidification. Through observation, monitoring, and modeling, we will generate scenarios on the changes in the Arctic Ocean environment. Physical, biogeochemical process, ecosystem response, future scenario changes, DB-based KAOS advancement are the purpose of this phase. For the physical process studies, we will look at the characteristics of those outer mass changes and changes on the ocean current system caused by the Arctic warming, and what kind of factors the Arctic warming is driven by. Previous 5 years of research found the distribution of the summer waters in the Arctic. So we will be, based on this, looking at the pacification and Atlantification of the Arctic Ocean. For geobiochemical research, we will also look at the acidification distributions, freshwater flux, to look at the Carper cycle and the CO2 flux. And following the sea ice research, we will look at the marine response when there is sea ice and when there is not, and how this overall impacts the food web. So we will be looking at the changes in the sea ice, how it impacts the marine ecosystem and living organisms. And this KAOS project will look at a new area of the interaction of the marine ecosystem. So in the past, we only looked at melting pond and looked at the energy balance in the melting ponds, but going forward, in order to conduct research on the interaction, we will attach various sensors on the melting pot to look at the interface and interaction between ocean and sea ice. And based on all this observed data, we will look at the biogeochemical process modeling, and we will generate the scenarios that are presented by the IPCC by clarifying the uncertainties. So the K-Aware project is led by Kubri and Araon, with many collaborative partners in Korea and also abroad. In particular, as the Arctic Ocean is vast and EEZ is well developed, and there are many political challenges. So with only solely the scientific purpose in mind, the US, Canada, Russia, Japan, China, and Korea will have already produced specific Arctic group. And over the years in the Western Pacific, we have shared data and conducted research. And recently, because we cannot understand the entire Arctic Ocean based on this very small area of study, we wanted to look at the Pan-Arctic as a whole. So we set up a program called Synoptic Arctic Survey that will observe the entire Arctic Ocean by segmenting the ocean and each of the 8 nations taking on the research. But because of COVID-19, the progress has been stalled. But all the data produced will be provided through the web-based KAIOS system, which will further be advanced, and anyone with an email ID can easily access the system and share data. So that is how the KAIOS system is built, and going forward, KAIOS will continue to be advanced. So I presented on the marine research conducted by COPRI. Thank you very much. Thank you, Dr. Yang, for your presentation. So next, I would like to invite
Next presentation on outlook of Arctic seabed environment change. We have Dr. Jin Young-gun from COPRI to present on this very topic. Very nice to meet you all. I am Jin Young-gun from COPRI. Let me now talk. We just talked about the changes in the oceans, and let us now move on to what's happening in the Arctic seabed environment. The picture on the left. The Arctic Ocean is 60 times that of the Korean Peninsula. It's similar to the Antarctic. And more than 50% of the Arctic Ocean consists of a continental shelf that is has a depth less than 100 meters. And on the right, we have the permafrost, frozen land for more than 2 years. And 24% of the Northern Hemisphere is a permafrost, and half of that is underwater. As mentioned, we're seeing fast warming in the Arctic and sea ice rapid decline we are witnessing right now. Not only we're seeing the changes here in the oceans, in the waters, as well as in the atmosphere, but in the subsea, we're also seeing these major changes. And this is a video. If you see the video here, this is the seabed, and the permafrost of the seabed emits methane. This is quite interesting, where we are seeing these outlets of methane. When methane goes out in the atmosphere compared to CO2, it's a greenhouse gas that has a magnitude of 25 times that of CO2, which will, of course, exacerbate global warming, which will go into this cycle of facilitating global warming, melting of the sea ice, melting of the permafrost, and then further emissions of methane. This feedback, if this loop continues on, then it will amplify global warming. In other words, we can call this the Arctic climate feedback time bomb. This is what the scientists are forecasting going forward. The emissions of methane not only increases the temperature, but due to the climate change, the associated climate change, it will lead to major economic damages. In 2013, Nature has indicated the damage, which is close to $60 trillion. And according to The Guardian, the Arctic methane deposits are started to release, and that we're seeing a faster pace of the release of the gas. As was mentioned, in 2012, we've seen an extensive decline of sea ice. And in 2018 and 19, this decline is to continue in record levels. And in the summertime, we may be seeing zero ice in the Arctic. Due to the rapid sea ice decline, for scientists that explore the Arctic, of course, can be an opportunity to explore. Up till now, there were inaccessible areas due to the sea ice. However, now it has opened up, and we can go in to unearth some unknown truths. In addition to COPRI, we have a Korean team and also international joint research teams. And in 2 areas of the Arctic, we're currently engaged in subsea exploration past the Bering Sea and moving on to the Arctic Oceans. In the west and the north, we have the Chukchi Sea and the East Siberia Sea. So that's one area. And moving on to the east, we have Beaufort Sea, especially in the Canadian waters of Beaufort Sea. From 2013, we've been engaging in expeditions 3 times. And in 2020, we were to go to East Siberian Sea. However, unfortunately, due to COVID-19, we weren't able to engage in the expedition for this year. So the question that we have are the following. The subsea permafrost, is it really melting right now? And get the gas hydrates, is it to be released? And how much methane is to be released? When it meets the atmosphere, will it exacerbate global warming? And is this a local phenomenon, or is this something that's taking place across the Arctic? So we were to compare these 2 sites. And as I have already mentioned, there are areas where we weren't able to explore. 90% of the Arctic Sea was inaccessible. However, we may be able to go into these regions and also to understand new truths about nature and humanity. Therefore, our research is also focused on that. There are many institutions that are involved. We have the US, Canada, Russia, Germany, and Japan involved in this project. And in Korea, we have, of course, COPRI, and a total of 6 institutions. 2 government-sponsored institutions and 4 universities are involved right now. And we have oceanography, biology, geochemical analysis, biogeochemical analysis. So multidisciplinary research is underway. So from the bacteria to the microorganisms. As you can see on the slide, there are an array of topics that we're currently researching. And to engage in in-depth research, we are using the equipment and facilities on Arawon, as well as those from the other international organizations. So we want to understand the geology, the biology, as well as the atmosphere. In the western area, in the East Siberia Sea and Chukchi Sea, we had 3 sessions of our expedition. So let me give you some information on that. So these are the high seas in the Russian waters. We weren't able to, of course, have access to those waters. In 2016, out of the 3 sessions, we had about mid-level ice. In 2018 was very difficult, and in 2019, we had the least ice. And in 2018, please refer to the picture where there was a lot of ice in front of the Arawon. But in 2019, you can see that there is no ice. We've just seen open seas. The Chukchi Sea and the East Siberian Sea. Let me go into these 2 locations. First, the Chukchi Sea. Chukchi has a depth of 500 to 1,000 meters, so it's quite deep waters. Our research target is gas hydrate. Gas hydrate is like ice that can burn. And here we've looked into the geology of the subsea area, and it was quite interesting. Here, there are these 3 mounds. We identified 8 mounds. And this is something that can be only seen at this site. This is a very interesting geological format. From 3 meters to 6 meters, we utilize these drilling equipment and facilities to sample the sediments. The areas in black are the typical subsea settlements, and the white will be the gas hydrates. And from these two mounds in red are where we've identified gas hydrates. On the ships, these white materials are the gas hydrates that were identified. It's ice, very cold. However, there's a lot of methane gas inside, so you can light it up. And as you can see here, it burns. Gas hydrates are located in various sites across the world, but in the Arctic, we've never seen it found. We were the very first ones to identify gas hydrate in the Arctic region. The gas hydrates, in order to understand whether it's identified in vast areas, we've engaged in this exploration. This is a depth of 1 kilometer, and this indicates the sections, the geological sections, and we see evidence of gas hydrate, which is a BSR layer, and we've been seeing extensive BSR layers indicating that gas hydrates are deposited in this particular site. So the deposits and the distribution is something that we're trying to model and map out right now. And this year, for the first time in the world, we discovered gas hydrates here, and we released a paper on this finding. And this is a continental shelf in red. A continental shelf 100 meters below water, the permafrost that can be found there. In 2016, there was no information on this area when we engaged in our exploration. And in the inner sides of the continental shelf, we were able to find a methane concentration in the water layer that's 10, 20 more times greater than the typical water layer. And we wanted to understand whether this was just a temporary phenomenon or whether this methane concentration is just something that was here for good. And this can also link with our research questions where we need to find the answers. We went back in 2018, but there was so much ice, and we measured methane under such a circumstance. And last year in 2019, we did not have ice. And we were able to put in place a well-knitted site map to measure the methane concentration in all of the sites. This is Araon. As you can see here, we have many measurement devices, and the results for the past 3 sessions in 2016, 18, and 19, when we had a lot of ice, depending on the circumstance, it was quite different in terms of the environment, but in this very region, methane concentration recorded quite high. Now the slide indicates the high concentrations of methane that we discovered. Not only that, another discovery was the manganese nodules. It's typically found in the Pacific Seas and the Indian Oceans and the Pacific Ocean in deeper waters. But we found this in the Arctic, and we believe that this has to do with climate change, and we're currently engaging in research to understand the formation. And in Canada, we had 3 exploration sessions. This is the Canadian waters, so we needed to seek approval from the Canadian government. In 2013, 2014, and 2017, we engaged in these expeditions here in the Canadian waters. We wanted to understand the distribution of the permafrost. Before this project, we didn't have the chance to utilize geophysics information. The areas in red are the permafrost, and as you can see, we were able to identify the structure with this expedition. And not only that, there is this interesting geology that emits methane. It's what we call a mud volcano, and in this area, we've launched a remote operated vehicle, an ROV of the US, and an AUV, an autonomous underwater vehicle. By using these vehicles, we were able to enhance the resolution by a meter. Typically on the ship, it's multiple meters. However, using this device, we can bring up the resolution by a meter. And this indicates the activities of the volcano. You see the gas being emitted as well as the mud coming out from the volcano, and this was all taped. We also looked into the temperature at the time of that eruption subsea. We identified gas hydrates in the process. Our future research will be focused on the Central Arctic Ocean, the high seas of CAO. And we would like to understand the geological history that goes hundreds of years back. There is an international joint program of IODP 957 and IODP 357, where we want to utilize the ARA-owned facilities and equipment to be involved in this research on the paleoceanography and geological history of the Arctic Ocean. In lieu of time, I wasn't able to go into the details of our project, but I do want to say that we're actively engaging in this research, and it was a great pleasure to share this with you. Thank you very much. Yes, Dr. Jin Young-gun, thank you for your presentation.
The third presenter will present the Korea's monitoring and prediction efforts for Arctic future prospects, and the presenter is from Division of Atmosphere Sciences of COPRI, Dr. Kim Joo-hong. Good morning. I am from COPRI. My name is Kim Joo-hong. So, as has been presented, I will look at the rapid Arctic warming impacts on weather extremes in Korea. I will provide you with a background of the research being conducted by COPRI on this topic. And as you know, recently, weather extremes such as cold wave, heat wave, flash floods, the severe droughts, and tropical cyclones have grown very, very rapidly. As you can all feel, there are statistical data on such events, not so much in Korea, but if we refer to the data from the US, this is the Munich reinsurance company that compiled the data on loss events over the past 30 plus years in North America. So you can see the general growing trend of loss events. So natural disasters are the major contributors. But when it comes to these disasters, there is the mid-latitude and commonly found phenomena in the mid-latitude. So during winter, there can be cold waves or extremely high temperatures during summer or winter. And what we commonly see in the mid-latitude is blocking. Blocking means that the air stops to flow. The air naturally has to flow from west to east in as the direction of the Earth's rotation. But when the air stops its flow, extreme weather events may occur. So when we think of extreme weather events, you can naturally think that air blocking is involved. So in the Earth atmosphere, the blocking naturally occurs, in fact. So the atmosphere can flow in two different forms. On the left, there is the straight jet stream, where the jet stream is really a very, very fast flow of air that flows from east to west in a straight line. But in other times, there can be a wavier jet stream with many curves. So when this happens, the air that was trapped in the Arctic flows downwards to the south. And when that happens, a very, very strong cold wave can hit. Or when the air travels upwards, there can be extremely warm weather. So cold wave and heat wave are both connected to the Arctic. Although they may seem to take place in remote places that are distant from one another, but they are actually connected. So how do these two different jet streams and their state basically affect us? Well, in theory, the polar tropical temperature difference can impact the state of the jet stream. So when the poles, near the equator, the earth is very warm, and near the poles, the earth is very cold. So basically, there is a wind flowing from the west. But depending on the temperature difference, the wind can grow weaker or stronger. When the temperature difference is low, the jet stream can become wavier. So when there is a strong blocking phenomena, the jet stream becomes wavier, and that leads to more extreme weather events. And as you have seen many times so far, this chart shows how the Arctic is warming faster than the rest of the world. This is changing the current state of polar tropical temperature difference. And so the jet stream will lead to more and more extreme weather events. So that is basically the theory that scientists have. But the Arctic is warming, and during winter, the warming becomes more distinctive. In the past decade or so, you can see that the Arctic has been warming, with indicated in dark red. In Eurasia or North America, you can see that the temperature is actually dropping. Scientists call this phenomenon a warming paradox. And this may relate to how much stronger the cold wave becomes during the winter. So in this chart basically shows and indicates how the Arctic may impact the weather in the mid-latitude area. But we cannot conclusively tell you the answer, because there is natural oscillation and volatility, and we cannot tell for sure whether global warming is reinforcing the extreme weather events in the mid-latitude area as a result of the Arctic force. But this is one of the topics that we are currently looking into. And as you can see, the Korean Peninsula is not right in the middle of the polar area and the mid-latitude area, but we are somewhere slightly deviated from that. So we are on the peripheries of the warming Arctic and the colder Eurasia. So it's very, very difficult to see whether if the Arctic, when the Arctic gets warmer, it gets colder in Korea. So this complicates things and makes it more difficult to forecast and predict the weather. But to better understand, we are looking at the subseasonal to seasonal climate predictability to enhance the predictability. And one of the research in this field will look at K-POPs, the COBRI PKNU climate forecast system. Has built the Korea Polar Prediction System from 2016 up until 2016, we have conducted research, and based on the research, we have built K-POPs. And with the Korea Meteorological Organization, we are sharing data as well. So it looks quite complicated, but in fact, the model is based on atmospheric data. And what is important is that COPRI looks at the Arctic sea ice and the sea ice conditions, which are entered into this model for prediction. So that is the key part of the system. Globally, this very system is quite the first of its kind globally, really. So among the season prediction models, not many incorporate sea ice conditions, but there are more increasing number of models that are currently moving towards that direction. And as for predictability, the more red you see on the map, and you can see the 1 month, 2 months, 3 month forecast, you can see the red is disappearing. Because closer you are to the timing of your forecast, so the shorter the forecast period, the more accurate you can be. So we want to compare the hindcast skills between K-POPs and CFS of NCEP. And you can see that sometimes our system is functioning with more accuracy than CFS. If you look at October, the more red you see, for the longer term forecast, the more accurate your forecast is. So you can see from early November, compared to CFS, K-POPs has more red, so it is more accurate. So it is basically more reliable in terms of our long-term forecast. But of course, when you go really into the actual forecast, it is very, very difficult to do. Although in hindsight skills, hindcast skills, K-POPs performed better than CFS. But when it comes to actual forecast going forward, it is very, very difficult and complicated to do. Because weathers and climate is very chaotic, and it makes it difficult for us to predict with high accuracy. But still, atmosphere scientists and modeling communities are making tremendous efforts to better understand our physical processes that we do not yet know, the numerical model, observing network, statistical techniques, looking into the post-processing of the data. All of this to enhance the predictability of our models. And we at COPRI also do everything that is described in this slide. We do the modeling and observing together to enhance our predictability. So this is the overall chart that shows the research being done. This year, we embarked on a new project, which not only looks at the atmospheric system, but also includes the ocean system. And we have many different study areas around the world, and we have our own and the Near-Lucent research base. And in the middle, we have a platform for intercommunication that also conducts simulation. For observation and exchange to take place, we are very stressing this intermediate platform. So when we get the data stably into our system, we can better predict the weather in the future. So this is my final slide. I only spoke about the winter cold waves, but during warm seasons as well, Arctic warming impacts the jet stream in the mid-latitude area by blocking the jet stream and making it wavier. This has already been reported by multiple studies, but it is even more difficult to predict the warm seasons, and so the forecast is less accurate. So we have a long way to go. And in summer, we had a very cool summer in July, and we had a very long monsoon season starting in August in Korea. So this is a chart from the Korean Meteorological Administration, and we believe that the Arctic warming has an impact on all these extreme weather events, but it is not a one single factor that impacts the jet stream. So that is all I have to say for today. Thank you very much, Dr. Kim Joo-hong, for your presentation.
Next presentation is on environmental change monitoring and research activities around the Arctic permafrost and fjords. We have Dr. Lee Yu-kyung from KOPRI to give us the presentation. Good day, ladies and gentlemen. I am Yu-kyung from KOPRI. Very nice to meet you all. Based on the presentations, we were able to understand the changes in the Arctic. Up till now, it was researched more so on the waters in the Arctic Sea or ocean. But I would like to introduce you to the research that was done on the permafrost and the fjords. This was sponsored by MSIT and the National Research Foundation. And we have Dr. Lee and Dr. Nam that led this project. Especially when it comes to Svalbard fjords, Dr. Nam Seung-il was in charge. And the monitoring in environmental change of the circumarctic permafrost, that was led by Dr. Lee Bang-yeo. So let me now go into some information or background behind this project. We are seeing environmental change in the Arctic, scientific interest, and the ripple effects of human survival increasing. Rapid increases in Arctic temperature is what we are witnessing right now. So we need to understand this and prepare for the future. Especially with the thawing of the permafrost, carbon dioxide and methane is being emitted. And this, of course, is accelerating global warming. Due to global warming, we're also seeing a quick an acceleration of coastal erosion. Svalbard is understood as a key geographic position between the northern extent of the North Atlantic Drift and the southern limit of the Arctic sea ice margin. So it's important to understand the paleoclimate change of the Arctic. In order for us to engage in the role, the scientific role as an observer state in the Arctic Council, we need to establish a sustainable monitoring system for changes in the Arctic environment. So what we did was engage in a research on permafrost and fjord environmental changes by securing technology of reconstructing paleoclimate changes from the fjords. And this is the average temperature of October 2020. And if we compare with 1981 to 2020, you can see that the temperature was 5 degrees Celsius higher. It wasn't a cool autumn, but it was a very warm autumn. And this increase in temperature, what kind of impact does this have on the Arctic? And just before that, I just want to mention that we also implemented core source technologies for continuous monitoring of extreme environments and securing a system for measuring quality data. The permafrost, the decay is very slow, so we do see certain organic matter in the permafrost. And especially the carbon stored here is about 2 times the amount of carbon in your typical atmosphere. Scientists say that with the increase of temperature, they believe that we'll see more plants growing, which will absorb CO2, where the Arctic will be seeing lower concentration of CO2. For the first 15 years in our observation, CO2 concentration did seem to go down. However, as time passed by, we saw that the concentrations of CO2 increased. And scientists say that the microorganisms due to global warming started to be facilitated. It was asleep, but now awake, and it starts to breathe. And the microorganisms and their breathing have led to this change in carbon concentration. This is according to the scientists. And in addition to that, we're seeing many fires in the tundra area of the Arctic and the taiga region. And when we put out the fires, of course, we see CO2 being emitted. And with the thawing of permafrost, it collapses. And once again, the CO2 in the layers are released as well. Our research team wanted to understand the various ecosystems and climate conditions of the permafrost. Therefore, we have set 6 observation nodes, and our target was to engage in stable operation of these nodes. And based on this, we wanted to develop a comprehensive monitoring technology for environmental changes in the Arctic and also achieve the basic information that will help us to further forecast. Based on the data that was collected, we wanted to understand the current status and also contribute to forecasts of the future. And not only that, we also wanted to contribute in the process of policy making. For the past 10 years, these are the sites that we ran. Starting from Alaska, we have Canada, Norway, Svalbard, Greenland, Iceland, and Russia. This was the order as the process of how we set the sites in place. Methane and CO2 concentrations were also measured seamlessly, and various factors with regard to climate change are being monitored. Not only that, we also wanted to understand what kind of impact the climate change will have on the living organisms in the Arctic. So multidisciplinary research is also underway. Permafrost maintains a temperature below 0 for 2 years, and during the summer season, the surface may thaw, but then it will freeze again, and we call this the active layer. However, you see that we see the plants with photosynthesis. We do see carbon, and then when it dies off, all of the carbon organic matter will accumulate in the permafrost and the active layer. And organic decay and organic matter thaw will take place where CO2 is released, and this carbon cycle continues on. But this carbon cycle or this carbon feedback is what we're monitoring. And in addition to that, in the thermokarst lake and the fjords, past history is accumulated. And we analyze the factors of these sediments to understand when Arctic had higher temperatures. We're trying to restore that state because this will give us information on what kind of changes can be foreseen when we do see temperature rise in the Arctic as we're seeing right now. These are the 6 observational sites, all of the facilities and equipment that were put in place. CO2 and methane needs to be monitored, and you see the equipment to do that. Not only that, black carbon and DMS and aerosol are some of the factors that impact the temperature of the atmosphere, so we also measure such matter. And with increase in temperature and with increased precipitation, this was something where we wanted to model, so we have such modeling equipment as well in these sites. But of course, the Arctic, this is not our territory, and we weren't able to install this equipment right away. It was on a different jurisdiction and territory, so we forged an MOU with various national institutions and also opened up local labs. We put in a lot of time and effort to have the right platform in place to enable us to have our facilities and equipment on site. There were, of course, some of the costs that were hidden. In order to maintain an international network, we need to continue on to observe the site, and joint collaboration and research collaboration is necessary. We engaged in not only international collaboration, but also with many research institutes and universities in Korea. We cooperated with them to run these facilities and equipment, and also we're focusing on nurturing future talents in this domain. This is the sites sampled from the fjords of Svalbard. In order to sample the sediments, we, of course, needed partnership with Norway, so we had this joint research with Tromsø University. For the past 10 years, we focused on developing monitoring technologies and also acquiring the sites, and we were successful at that. Based on these observation nodes, we will continue on with the monitoring for the next 4 years, and we would also like to understand the response of Arctic towards climate change. Climate change has an impact on the ecosystem of the permafrost, and the ecosystem of the permafrost will, of course, impact climate change as well. So we want to understand this feedback. So the atmosphere, the permafrost, and the coastal ecosystem is something that needs to be monitored on site. So what we want to do is acquire this data and utilize this data for future research. For the past 10 years, we've been focused on acquiring source technology of the polar region. Understanding permafrost, understanding the characteristics, and understanding the biology was something that was key, and we, of course, made publications on that. And some are also in English, which, of course, helped us raise awareness of our research abroad. We will continue on to engage in these various public relations activities to actively promote the research outcome of Arctic studies. Thank you very much. Thank you, Dr. Yu Kyung, for your presentation.
And next, I invite the fifth presenter on the potential hazardous microorganism assessment due to global warming. We have Dr. Young-mi from the Division of Life Sciences of COPRI. Good morning. I am Lee Young-mi from the Life Sciences Division of COPRI. My name is Young-mi. This year, from June, we began a research titled Assessment for the Potential Emergence of Microbiological Risks in a Changing Arctic. And I would like to present the need for this project and the way forward. COVID-19 has stoked global fear of infectious diseases. And we are wearing facial masks and making presentations on video nowadays, which has really become a new normal for us. So I would like to give you a big hand to all of you for enduring the year 2020. And no one knows when this will end. And we are all very exhausted because of COVID-19. But I still wish you a happy December. And with that, I am wearing this Merry Christmas facial mask that I was given as a gift at a restaurant, and I would like to, I just wanted to show you this mask. And now I'm going to switch over to a ordinary mask and start my presentation. Emerging infectious diseases refer to diseases like COVID-19 that either did not exist or did exist, but are occurring at a quickly growing frequency or scope, unlike its limited scope in the past. So we call these diseases, infectious diseases, as emerging infectious diseases. And as you can see on the left, these infectious diseases have steadily occurred around the world. And although this number is from a long time ago, the deaths by infectious diseases accounted for 25% of all deaths around the world, like war or hunger. Infectious diseases present a challenge to the human survival. In fact, new infectious disease of the last century has become a huge threat to the humankind, and is even stoking a horror to everyone around the world. And in 2018, the WHO announced that unknown disease X that does not yet exist could cause a global pandemic. And such an infectious disease calls for countermeasures early on. As seen with the case of COVID-19, I think that COVID-19 is the first disease X defined by the WHO back in 2018. And preemptive response for such illnesses is very, very important. We heard about climate change and different resulting phenomena from another presentation. So climate change not only causes natural disasters such as flood and heat waves, but impacts the human health. According to the WHO and the IPCC fourth assessment report, with rising average global temperature, the spatial patterns and distributions of some infectious disease vectors altered, which raises concerns of human health impact by these infectious diseases. And also in 2019, in the Nature Review Microbiology, a paper called Scientists' Warning to Humanity, in fact, mentioned the risks of infectious microorganisms associated with climate change, and also called for the examination of microorganic response to climate change, and underlined the need to include microorganism-based research in the policy development and management decisions as we prepare against such a rise in infectious diseases. So the possible correlations between climate change and infectious diseases make us turn our eyes on the Arctic. The Arctic is warming faster than the rest of the world, and a significant part of the Arctic is covered by permafrost. But as you can see in this graph, the temperature of the permafrost has been growing along with the atmospheric temperature very, very quickly. So as the permafrost and the atmosphere becomes warm, inside the permafrost, there can be geological changes that are triggered, and also the existing microorganisms that may have accumulated in the low temperature may be activated and released into the atmosphere. Therefore, such warming of the atmosphere and the permafrost can also lead to infectious diseases that are caused by hazardous microorganisms. So looking into the hazardous microorganisms is important not only for the 4 million residents in the Arctic, but for all of us in the entire world. Because these hazardous microorganisms dormant in the permafrost can affect all of us. In fact, back in 2016, in Siberia, thousands of reindeer and even humans died because of the anthrax bacteria. And as for the cause of this death, there are many theories being presented. One of the key theory being that the anthrax bacteria that laid dormant in the permafrost were activated by global warming and released into the atmosphere by the heat wave. Climate change, global warming, and infectious illnesses are possibly correlated, as you can see in this case example, and there is definitely need for research into this new topic. And we also found variola virus, which was thought to have become extinct from the earth, but we found the remnants of such viruses from bodies found from scores of years ago, and we also found pirovirus Sibericum separated from the permafrost from 30,000 years ago that was known to infect eukaryote amoeba, although this bacteria does not infect the human body. So the thawing of permafrost could possibly release this pirovirus and threaten human health. Anthrax viruses or variola virus has very, very high fatality. But not and just because these viruses are there, we don't have to be too afraid, but we also have to be very aware and look into the scientific basis of whether these viruses can lead to serious health impacts. So to better understand this correlation, we launched the One Health project. As you can see, One Health is a concept based on the indivisible relationship between the health of humans, flora and fauna, and the environment, and considers all actors in an integrated manner. So our life scientists, environmental scientists, policy developers, all have to come together under One Health in an interdisciplinary research to build a scientific base for our approach. And against this backdrop, in fact, led by the Arctic states, a network to look into the infectious diseases, mostly on animals and humans, has been set up, led by the Arctic Council. The Sustainable Development Working Group, or SDWG, of the Arctic Council launched the One Arctic, One Health program. To look at, for example, food poisoning pathogens and conduct a consistent monitoring of such pathogens. And as Dr. Lee has already mentioned, within the circumpolar permafrost, COPRI has conducted a decade of diagnosis and analysis on the environmental changes taking place. So we have not only built these key study areas, as you can see on the map, we closely monitor the environmental changes there and also look at the microorganism dynamics. But unfortunately, for more efficient research, we have not yet had a hazardous microorganism research as a topic. And so this is the backdrop of how this particular research came to be. We wanted to look at how the climate change in the Arctic can impact microorganisms. And first, we want to see whether there are hazardous microorganisms here and how they relate to the environment and what their mechanisms are. And we want to build a international and domestic research network to share data. And when making policy decision, we want to provide the scientific base and evidence. And based on all this, we want to quickly diagnose the existence of hazardous microorganisms to allow preemptive response. So in this project, we will firmly establish the analysis methods for identifying the hazardous microorganisms to see if they exist in the Arctic and what kind of correlations they have with the environmental factors. And in this monitoring effort, under the One Health concept I described earlier, we want to look at the flora, fauna, and the surrounding environment. And secondly, to understand the hazards of these microorganisms, we want to look at how their mechanisms change depending on the environmental factors. And last but not least, for this research, we need an international and domestic network. And as I said earlier, not only bioscientists, but environmental scientists, healthcare, and public health professionals need to be involved. So everyone from the relevant industries and academia, they will all be engaging in this network, and we want to build a strong international collaborative network as well. So we want to fulfill our responsibilities as not only an Arctic Council observer nation, but also to present right answers to the microorganisms and related infectious diseases that may arise in the world. So this Dr. Anthony Fauci said that the best way to deal with an infectious disease is not to respond after the disease occurs, but to prepare in advance. And this very particular project began in June this year. Also, it came a bit late because it started after COVID-19 hit, but I still want to ask you for your full support and interest. And let's just say that when we think it's late, it is actually not too late. So I ask for your support so that we can make a great achievement. Thank you very much. Thank you, Dr. Lee.
We have the last presentation for the session. Advancement into unexplored area in North Greenland through paleo-environmental and animal evolution research is the title of the next presentation. We have Dr. Park Tae-yoon from COPRI to present on this topic. I am Park Tae-yoon, currently engaged in Greenland-related research at COPRI, and it's a great pleasure to have the opportunity to introduce you to the unexplored area in North Greenland. North Greenland and the explored area of North Greenland is quite sizable. It amounts to the size of the Korean Peninsula. From 2016, COPRI has been very active to research North Greenland, and we were first. We were the first to do that amongst the other domestic institutions, and we believe that it deserves our efforts and our interest. Greenland is the largest island in the world, 20 times bigger than Korea, and 80% is covered with ice. And the unexplored area of the North Greenland is here. You can see on the northern tip, about 800 kilometers from the North Pole. In 2009, Greenland announced its independence from Denmark, and the total population is only 56,000, so it is a small country when it comes to population. But from the west to the southeast, we have the residents living there. In the east and the north, nobody lives there. And that's why this area has been designated as a Northeast Greenland National Park, and it's about 10 times that of the Korean Peninsula. It's the world's largest national park. And in this area, only 33 persons stay here year-round. And there are Danish military sites as well as research stations. And we are at the northern tip. And the very closest station is the Danish military site with 6 soldiers. This is the satellite image of northern Greenland. This is August 19th, 2001, and in 2018, August 19th. As you can see here, it was greatly impacted by climate change, and you can see that the ice is melting. However, meteorological monitoring is not being done right now. This is Station Nord, and we are about 390 kilometers west of Station Nord. In other words, in a 400-kilometer radius, there is no inhabitants whatsoever, so it's a very remote location. We go on a twin otter to access this area. It flies very low, so you can refer to all of the geology, and there you cannot see any traces of humanity. This is Sirius Passet, where our camp is located. In the summer season, land is about 20 degrees Celsius, so it's quite warm. However, even in the summer season, in the front seas, the fjords are full of sea ice, which is quite interesting to see, despite the warm weather. In 2016, we've made inroads into this region, and as you can see here in the picture, the camp size is increasing. And in 2018, we wanted to also add some further equipment and facilities. A polar igloo was something that we built to have our equipment. In July 30th, this was a high-resolution satellite image, and you will be able to see the structures that we built to store our equipment. I have a 4-minute video. In 2018, we put together this video, and this was when we were engaging in a site survey. We wanted to introduce this site to the audience. This is a twin otter, and we were visiting the station. So we paid a visit to the station, and then we went back on this twin otter light aircraft to go to our station. Of course, we do not have a runway, but the twin otter can land as long as it has flat land. During the summer season, it's quite warm and it reaches 20 degrees. You can see a lot of flora and fauna. You see the animals that live here in this region. This is a very famous volcano region, and you've just seen the 3D modeling.
많아졌어 이거.
So this was the series passed fossil locality, and we were located on the side of this fossil locality, and you see these animals. So they don't see many people, so they're very much curious. They get curious and they sometimes come closer, and you can see the rabbits as well as the wolves. So once again, it's at the northern tip of the unexplored area of North Greenland. In order to access these areas, you need a robust research theme. And we decided to focus on early fossils. This is important because we can understand the early forms of animals. In the past 4.6 billion years ago, there was no form of life, but in 540 million years ago, we've started to see these various types of animals, or the Cambrian fossils. And you may think that it would be interesting to see and understand what happened in the paleontology eras, and of course, the fossils can, if it's well preserved, it can give us a lot of information. However, we cannot preserve or restore the state of the years with just the fossils. However, here in this Arctic region, we also have some organic matter that can help us restore the situation of the marine life at the time and also understand the myths and life of the early animal forms. This is the fossil locality where we're working, and this was the lab where we've put together the images of the fossils. These are some of the highlights. In 2018, this was something that was on the papers, and on the head of the animals there is a white patch, and you can also see stripes. And this is the brain of this animal, or in other words, an old nervous system. So in 2018, we were able to release this article. What we're currently reviewing right now is a predator, a type of giant arrow worm, and we're currently doing a research on that. And this is the nervous system of that worm. In the future, we also want to focus on this, which is the earliest forms of chordates. It's like a fish. All of the mammals started off with this type of animal or life form, so that's why we think that this would be quite interesting. And the earliest chordate fossils can be found here in Sirius Passet. And as I've already mentioned, it has abundant flora and fauna, so a lot of ecological studies are possible. There are 5 types of mammals, 15 bird species, and about 3 or 4 species were dedicated to this region. And there are a lot of flora and fauna, but it's still yet to be explored. This is the musk oxen, the largest mammal here, and we want to find a quasi-fossil to engage in the NCT research. And the Arctic wolves, sometimes they come to our camp, but they're not dangerous. They're full of curiosity. This black plastic bag has the feces of us, and they really like this. And we also have Professor Ujusan. He took his bag and he urinated on his bag. And Dr. Lee is currently researching species, and based on Industry 4.0, drones are being used. Sensors are on these cameras, and you cannot see which is what. But if you look at the images from the centers, this is the nest of the bird based on the infrared light camera. And what we also did was, for the past year and a half, we looked into the meteorological patterns by utilizing the UAV. And next year, we're going to go to a different site, and we want to go to this large-scale lake, 46 kilometers in width. It was a part of the ocean, but it separated out into a northernmost large-scale lake, and we think that it's never been explored or researched yet, so it would be very much interesting, and we're going to be using these drone bones to understand this area. So let me summarize our research. Of course, vegetation-related research is possible, and not only that, birds and species, vertebrate animals can be researched here. Not only that, the marine ecosystem has not been researched up till yet here in the northern tip, so we can do that as well. And paleontology as well as other geological research can be done. And through the glaciers coring, we can go into the sediments and research on that, and satellites and other glacial equipment and facilities can enable us to do various research. But I want to talk about logistics. Right now, we have these tents. This is the best that we can do right now. It's just a camp, but in the future, in the distant future, we also want to build structures to put together a joint international outpost. This is something that we're planning for the future. So this with Copenhagen University and with the Denmark researchers, we're currently focusing on our work with them, also with the University of Bristol, and also we have Seoul National University and Max Planck Institute. And this Willem Research Station has been proven very helpful in our research. Thank you very much for your attention. Yes, thank you very much for your presentation.
Thank you very much for listening to all the presentations. And now it is time for a 10-minute break. Before we proceed with the floor discussion, thank you. think it is time to resume. So, and we would like to proceed with the floor discussion. I'd like to ask all participants to kindly take your seats. And now we will begin a floor discussion regarding the 6 topics that have been presented in the earlier session. We would like to invite the discussants, and the moderator will be Vice President Kim Jong-duk of KMI. Vice President Kim, you have the floor. Hello, as introduced, I am Vice President Kim Jong-duk of KMI. And this is the 5th APW, and for the first time, COPRI has launched the seminar on Korean Arctic research projects, so congratulations. And it was great to listen to very invaluable presentations about the fieldwork, and it is an honor to be moderating this floor discussion. I would like to thank all presenters for your great presentations. And we have 45 minutes for the discussion. We have 6 designated discussants. I would just briefly like to introduce the discussants. And the order of the discussion will proceed as the order of the introduction. We first have Dr. Shin Kyung-hoon of Hanyang University. Professor Kim Hyung-soo of Chungwon University. From Bukyong National University, Professor Kim Bang-min. From Post-Tech, we have Professor Lee Gi-taek, Professor Seol Woo-jun of Chungang University, and last but not least, Professor Woo Ju-sun of Seoul National University. I look forward to the discussions on this very interesting and insightful presentations. I would appreciate your comments and any way forward for the Arctic research for Korea. Please share with us your views freely. I'm sure that you will contribute greatly to the Arctic research by Korea. First, I'd like to invite Professor Shin. Yes, I am Shin Kyung-hoon from Hanyang University. First of all, thank you for inviting me to this important event, and I listened to all 6 presentations. I was deeply impressed. And the first presentation was, well, actually the keynote speech by Vice President Shin Hyung-chul was gave us a great outline about how the past decade of Korea's Arctic research was like, and you also gave us a way forward for the Arctic science by Korea. And the first presenter was Dr. Yang Eun-jin, and I would like to give you my comments on her presentation. So Dr. Yang presented about the research that she has conducted so far and some of the research I conducted with her in joint collaboration. And I think that I would like to present more about the future direction rather than the research conducted so far. And as we have been aware, sea ice melting is a very important issue regarding climate change and global warming. And this is one of the biggest issues we faced in the Arctic. The fact that the ice is melting and the fact that the permafrost is thawing would lead to more freshwater runoff into the Arctic Ocean. So this is happening across the Arctic. And of course, this will impact the search and rescue operations. And we heard during the presentation that the Atlantic waters is increasingly flowing into the Arctic. There can be a number of factors at play here. Physicists are looking into the physical factors, for example, and cold climate water will lead to the seed formation in the winter, and that layer is supporting the sea ice because it is the water is cold. But this water is becoming thinner and thinner, and I think now we have an even thinner sea ice compared to 10 years ago. And if you look at the water beneath this thin sea ice, we see a higher proportion of warm Atlantic water. And sea ice formation is decreasing in the winter, and Atlantic waters is related to this. And of course, when there's too much heating in the summer, the heat will remain during the winter to make the sea ice even thinner. So all these factors are at play. And because the global warming is progressing, I think that Atlantic water can be fed into the Arctic Ocean more and more. And assuming that we no longer have sea ice in the Arctic, then a major change will take place in the water mass, which will lead to biogeochemical changes in terms of carbon cycle or ecosystem responses, of course. So going forward, looking into the 3 to 6 years, you have plans for the future research. And of course, your primary focus will be on sea ice and relevant dynamics. You will continue to observe and interpret the data, and this will be a very important project. Thank you. Thank you for your words. And next, I'd like to invite Professor Kim
Professor Kim Hyung-soo, yes, thank you. I've learned a lot from the presentations, and it was a well-prepared presentation. I'm particularly in geophysics and geology, and geology has to do with studying the history of the Earth. And from this point on, the atmospheric changes will impact biology, and we'll be seeing this leading to permafrost as well as fjords, and then it will create or tectonic change, and then to paleontology. This was a major spectrum that we can see, and Arctic actually encompasses all that, which was quite interesting. So I think it's important to collaborate. It would be great if you can continue on with your collaboration with various disciplines. And I would like to comment on the Outlook Seabed Environment by Dr. Jim, especially on geophysics engineering. There are gas hydrates that you've mentioned that were first identified and discovered, and I would like to applaud and thank you for your efforts on this wonderful discovery. And as a Korean citizen, I'm very proud of your work. Arctic Partnership Week, I wasn't very familiar with this. So I looked into this, and I was able to see that the Arctic Economic Council from 2016 was established, that was separated out from the Arctic Council in 2016 to understand the economic opportunities of the Arctic. That's what I understand above AEC, and I saw the site, and of course it wasn't in detail, but there was of course an indication of this partnership week. Therefore, I believe it's great to have this platform to share all this information all together. And with regard to Dr. Jin's research, geophysics information, there's a lot of data. I'm sure it's pretty much the same for biology as well as atmospheric studies, but especially for multi-beam, for instance, this is critical data to understand and to study. And with Dr. Jin's support, I was able to go into this as well. And data to actually go in and indexing throughout the time series, it's very difficult to do. In the past, the software was very expensive, but now we have open source software, and we can also see cross sections of water columns by utilizing this technology. So I hope that you can further invest into this various technology, and also increase the number of resources. It can also be used for biology. So I think that would be great if you would consider going forward. And what happens is when we are unhealthy, we can see that our face, it loses fat, but then we get fat on our body. So in other words, Arctic is something like that. It's an indicator to show that there is this unhealthy symptom, and then when our body recovers, it would probably be the last region to recover from a disease or an illness or a challenge. We can see that it's important to monitor and observe to see any symptoms that arise from the Arctic, because it would be a key indicator. The Arctic Council, I think, could also cooperate in this effort to continue on to observe, to have structured observatories in place to monitor the situation of the Arctic. Compared to the Antarctic, Arctic may be a laggard in this regard. The CAOS project will come to an end this year, and the KOL project will move on to phase 2. And COVID-19, I think, can give us the luxury to review and look back upon our footsteps. So once again, I hope that as we've shared the presentations today, a multidisciplinary collaboration will be necessary to make sure that we didn't drop the ball in the process. So I hope that we can review that in this process. Thank you. Yes, thank you very much, Professor Kim. Next, Professor Kim Bing-min from Bukyong University, Bukyong National University.
Thank you for the presentation. It was very interesting. And during the presentation, I took some notes on my notepad, and I used up more than half of my pad because the presentations were so interesting. And it was a great learning session for me. And I really newly realized how interesting and fun Arctic research can be. So I engaged in Arctic research myself for the past decade, and as an insider, I had a different view about the Arctic research, but now as an outsider, as one of an ordinary citizen, to look at the field work and look at the beautiful pictures from the Arctic, it was a very interesting experience, and I was impressed by how much work is done by Korea. So as Vice President mentioned early on, I could not agree more. COPRI, various research and experience and the different steps of research were given out in a very logical manner and neatly organized manner first. And right now, Korea's Arctic research, I think, has a very good comprehensive composition. All of the research done by COPRI is second to none, I believe. And now I think that we need to ponder on the next step to take. We should not stop at being comprehensive. We must make sure that all these research leads to tangible results that really contribute to the people of Korea and also lead to unique scientific achievements by making further development. So we are now at a very important juncture for a very important future. So I think the last two presentations were particularly important. Dr. Park Tae-yoon, your research, in fact, should be one of the most important projects that COPRI must conserve, because the polar region connects past to present. It is trapped in ice and geology. There are the traces of the past that we can find in these uncharted worlds, which the humankind can share all together and to create better result outcomes and research outcomes. And that is where the value of polar regions lie. And Dr. Lee Young-mi, you mentioned a very new area of research. I think you're very, very excited to be pioneering into this very new area of research where there is not even an organized method of how research must be conducted. But I think that everyone is very curious to know how microbiology can connect to viruses and the daily lives. And to me personally, in fact, I'm not a relevant researcher in this area, but I often get questions about this area, and so I think there's a high level of interest in this research area, and I hope that your research can lead to produce tangible results. And more specifically to Dr. Kim Joo-hong, as Vice President mentioned earlier, after having a comprehensive research, we must think about the next step to take. So the Arctic global warming in climate change is closely related to the rest of the world, and we have had a comprehensive understanding of that correlation. But from that understanding, how practically can we explain or predict the extreme weather events of the mid-latitude or the Korean Peninsula, and how can COPRI contribute? I think you gave us a more concrete and practical questions. Every year, the Korea Meteorological Administration has a winter forecast meeting to determine whether or not the winter will be cold in Korea. And I have been a part of that meeting for the past decade. And the KMA, or the Korea Meteorological Administration, uses a UK-based meteorological model, which is really suitable for the UK and Europe. But in Korea, winter for 10 years has consistently been quite warm. And this model actually predicts that the Korean winter will always be warm. That is always the result of this model. But sometimes that is not really the case, because sometimes winter in Korea can be very, very harshly cold, and sometimes it can be warm. And Dr. Kim Joo-hong mentioned during the presentation that various processes in the Arctic, and for example, current models predicting too much ice and not being able to have an accurate forecast of the weather is the limitation with the current model. So I think COPRI has a practical contribution to make here. And in that direction, the most important contribution that COPRI can make is to engage in accurate prediction for Arctic dynamics and the weather. And if you look into this area more deeply, I think that it will be very helpful. Thank you. Thank you very much. Next, I invite Professor Lee Ki-taek. You are sitting in the back, sorry.
Yes, I am Professor Lee Ki-taek from POSTECH. I had a personal interest, and I looked into the research outcome of our scientists in oceanography, but I was so much surprised because 20 years back, before I was a professor, and now I can see that this discipline grew immensely in terms of the quantity and quality of papers and dissertations. But what's a pity is, of course, we do have regional limitations, but we have quality papers, but the impact of these papers are not as strong. It may be that we don't have enough track record, and this is something that will solve as time goes by. And I believe that research in Arctic and Antarctic will help us add on to our track record. The presentations of the 6 speakers elaborated on the potential that we have of making that a reality. Rather than going on to a particular topic, I would like to talk about just 2 points. In 2016, there was a public hearing on the second research icebreaker, and there was a question that I posed to the panelists. COPRI, if it engaged in Arctic research for 2 decades, well, what would be important it would be to review the projects and also understand or also select the core research areas for the future. And I thought that would be great if it would be understood by the citizens, and if the topic, of course, is important, but if we can also assess the capabilities of the researchers of these 2 or 3 flagship projects, I thought that that would be desirable, because this, especially if it deals with a basic natural science question, that would be great. And I did mention that even without this public hearing, we would be able to draw some better, more fruitful conclusions. So I truly hope that internally at COPRI you will have that time or have that opportunity to do that. Our speakers talked about their own projects in a comprehensive fashion, but of course it had to do with the limit of time. But I thought that it would be great if there is a project that can integrate all this. For instance, we had the ice, oceans, atmosphere, and permafrost. And from decades and hundreds of years, of course, there was paleontology as well, but there are these reservoirs that will change throughout the decades. And especially these 4 areas are closely related. And it would be great to draw a common denominator. It could be DMS or methane. The production of this, of how it's done away with, it's all connected like a big cloud. And an integrative long-term field program, I think, can be beneficial. So for instance, Dr. Lee talked about the 6 sites, the observatory sites. And if it's run well, I believe that this could be a very important platform or a useful platform to integrate. It covers the Arctic space and particular gas, of course, reflects the oceans as well as the cryosphere. And I believe that this will be data and information that can help devise a sound plan for research in the Arctic. Up till now, the ocean process, if we set a process, we just focused on that silo. It was very difficult to devise a plan in advance. But let's say in the atmospheric process, if there is any relationship or any probability of having a certain event happen in the oceans system, then this predictability or this forecast will probably raise the robustness of this integrative study. I just wanted to mention that this is the right timing to actually make that next leap forward in integrating all of these disciplines. Yes, thank you very much. Let me move on to Professor Sal.
Thank you. Good morning. I am Son from Chungang University. My area of research is microbial mechanism. And this is an area where I am quite familiar with. And today, Dr. Lee embarked on a new project, which I had already heard about before today. And in relation to global warming, is simply put, the Arctic is melting, and the previously frozen viruses, bacteria, or other microorganisms and pathogens really could be released as the ice melts in the Arctic. And this may have some potential impact on animals and human life, and that is what you all want to look into in your research. This is one of a very long-standing question that we had in our minds. Whether the answer is yes or no, because we continue to witness such phenomenon, this area cannot be disregarded. And in this sense, rather than just being suddenly ambushed by such a phenomena, it will be much better to know about it in advance and prepare in advance. And I think that is the background of your project. But rather than challenging your project, I would like to just describe as an alternative maybe. You can conduct samples from another researcher to conduct your research. It is impossible to cover the entire permafrost in the Arctic Circle, but surveillance and monitoring will require a multitude of wide-ranging samples. In building an international collaborative network, that you mentioned in your presentation and in international cooperation. I think getting as much samples as possible will be most important, and it will be challenging, really, to analyze all these different samples. And I think all six projects we heard this morning are very, very interesting and important. And if you can take a step further, and if all the other five other topics and projects can chip in and help out Dr. Lee, it'll be very, very helpful. And I think this kind of collaboration will be important as well. And for the One Health concept, as former President Obama mentioned, the target of One Health is the resistant bacteria that are resistant against antibiotics. So if there are pathogenicity of these multiple resistant bacteria, it can be very dangerous. So the antibiotic resistant genes are already widespread, and we do not know, we cannot predict what kind of new resistance can be developed by these genes. So why don't you, it'll be good to research this area as well. Pathogenicity mechanism, I think, is an area that you can simply compare in terms of similarity of the existing pathogenicity. And how, no matter how much these pathogens are released into the air, as long as they do not have an infectious illness vector, they will just simply disappear without any harm, without doing any harm. So what's important would be the people, the animals around these viruses. There can be viruses that can infect both animal and humans. So we think this is an area that you need to look into. So at the end of your presentation, or actually the final presentation by Dr. Park, I think indicated some good potential areas for collaboration with you, Dr. Lee. And we are living in an age of microbioorganisms. So even if you find a very ancient microorganisms, I think they will be fine. If you can connect that work with the work of Dr. Park, I think you can also lead to some new research topics as well. That is my proposal. Thank you. Thank you, Professor Wu. Actually, Dr. Cho, thank you. And next, Professor Wu from Seoul National.
As I was listening to the presentations, I was able to feel that not only COPRI, but Korea now can research all domains, including the atmosphere, the seabed, the oceans, the biology, the atmosphere. And I was very impressed with the research outcome, and I was very happy to hear that. And especially climate change, environmental changes, our pending issues are something that we need to respond to. And it also there's of course a lot of research on that and also on resources, but with regard to pandemics and also paleontology to look into animals that lived 500 million years ago. This may be a bit different from the pending issues, but it was quite interesting to see that it's being planned out and that research is underway. I was quite impressed with that. Because my area research is geology, I would like to just briefly talk about Dr. Park Tae-yoon's presentation. Well, first of all, you talked about unexplored areas, and you focused on some of the challenges going forward. And I know that you did not have enough time to go into your project, but it was on the northern Greenland area where, as mentioned in the summer season, in the coast or in the fjords, it was full of sea ice. But now we no longer see the ice right now. This is a major environmental change. And due to this change, in your research topic, you've talked about the major animals, the flora and fauna. In addition to the microorganisms, you talked about ecological research on the flora and fauna. And I think that there will be many changes that will catch our eye in the future. The last slide had many pictures, and there, in addition to the sea ice, we also had the polar bear as well as the seal. But this is an area where polar bears do not live. When we go and engage in a field survey, of course, there's that risk of polar bears. However, the area that you were focused on had no polar bears because that was quite interesting. There are animals that cannot fish because of the sea ice, and that's why you don't see polar bears on that site, which was quite interesting. But let's say that if we do see a thaw of the sea ice, then the predator on the tip of the food chain will emerge, and this will, of course, change the ecology of that region. And I think that in the near future, we will be seeing these changes, and soon enough, it will be in your reports. And the core of your research project had to do with fossil research. So once again, it goes back 500 million years or 520 million years. You've looked into the evolution of the animals since then. There are geological data that you would, of course, need as a backup to pursue your research, if I'm correct. In addition to the fossils, there are also the rocks that have the fossils. And when you map the fossils, you may be able to see or discover new fossils in the process. And these geological information and data at the end of the day can also connect to resource deposits. So once again, with the changes in the environment, well, Greenland, of course, we do know that there are a lot of resource deposits in the area, in the island. But with the loss of sea ice in the northern part of Greenland in the near future, accessibility will, of course, improve, meaning that resource-related activities can be done. And when that time comes, basic geological data, of course, needs to be provided in advance. International cooperation was something that you've been doing quite well, but especially the Yulon Station or Denmark and Greenland, there are specific infrastructure, research infrastructure, where you can take advantage of these infrastructure, and I think some synergy can be created in the process. So I believe that it can play the role of a hub. And last but not least, Dr. Lee, Yu-kyung. I do know that it was very difficult to acquire the nodes, the observation nodes. We have Araon and we have existing stations, but for research that actually are beyond the scope of these stations, the existing stations, probably needs further investments and support, especially in terms of infrastructure. And as was mentioned by Vice President Shin, Arctic research, the platform for Arctic research is now expanding in scope. And this also means that we also need infrastructure support that can help us flourish in that ever-expanding platform. So that is all. Thank you very much. Yes, thank you. I would like to extend my gratitude to all of the professors for their comments, and I can see that you were very positive about the outcome of COPRI, and you've also given us some suggestions for the future. The researchers, as they plan for new research and as they engage in their current research, I think that it will be would be a good advice in setting the direction forward. We do have some time remaining, and there were comments by the panelists, so if there are any speakers that would like to comment on what was mentioned, or in lieu of time, if there was some areas that you weren't able to present, I would like to give you the opportunity to do that. So starting from Dr. Yang, or you may raise your hand. The order is irrelevant, but why don't we start off with Dr. Yang?
Thank you very much for your very good advice. Listening to the panel's comments, I recall that the first time we went to the Arctic on the Araon back in 2010, we didn't know how to place our equipment in the sea ice, and we didn't know how to install them on the ice. So although we conducted research for the past 10 years in the Arctic, in fact, regarding Arctic sea ice research, I think only recently we started to accumulate know-how. More than 200 million wons worth of equipment were lost in the sea. And in the process, we built the basis for Arctic research. For more than 5 years, I have been conducting research in the same location, and 5 years was quite short. And sea ice change really happens like any passing event in the Arctic, and each year the pattern is different. So to observe a long-term pattern, 5 years was not a long enough period. So based on your advice, I would like to look into my next step in the project. I am taking your advices very seriously. Based on the research so far, how can we connect the Arctic research into ocean and sea ice dynamics? And Dr. Lee, your comments, I really could not agree more, because 2 years ago, I looked at the sea ice and ocean integrated research, and I conducted a feasibility study in the Arctic about this topic. And I felt then that our project is supported by Ministry of Oceans and Fisheries, and atmospheric research is supported by the Ministry of ICT and Science. And without the intergovernmental collaboration, it will be very, very difficult for us to conduct research in the Arctic. Regardless of which ministry supports, I think we need to make efforts to really engage in a closer and closer cooperation. Thank you very much. Yes, that I really wanted to mention earlier. I forgot. So just to take one example, all the presentations made today are correlated. For example, in the permafrost, we witnessed the Siberian wildfire. If there is such a hot event that occurs, or if warm water flows into the Arctic Ocean, there will be much energy flowing into the Arctic. Methane hydrate will be released, water will become warmer, and the ecosystem will completely change. And it is happening, unfolding before our eyes. And as the doctor just said, because of the ministries that are engaged are different, and they cover different areas of work. So if the government can monitor the overall research areas and help us lift the boundaries between different ministries, it'll be very helpful. And ocean, atmosphere can be comprehensively looked into. And I would like to ask for the ministry's full support on this. Thank you.
Araon has enabled us to engage in Arctic research in earnest, and as was mentioned 5 years back, we really didn't know where to begin. So for the 5 years, it was for us a learning experience. We wanted to understand what is where, and also plan out on how we can research what we are seeing. In addition to that, our exploration and expedition techniques were something that we wanted to expand globally. It was also about, it was the 5 years that helped us, and it was about bringing up our level at par with other international communities. And starting from next year, we're going to embark on a 6-year project. And the experience, the outcome for the past 5 years will be enhanced in sophistication for the next phase project. We do now understand certain regions and certain research topics that needs greater interest. So what we want to do is refine our research and also subject a wider region, and we will be doing that for future projects.
Thank you for your great comments. My presentation did not mention the word observation, but you did raise the issue of observation. I actually conduct much observation in my research, but in terms of studying the climate, introducing you to the observation in this area was quite difficult to do in my presentation. But climate research involves data analysis and modeling and prediction, because climate research looks into the many observation systems in the mid-latitude. And all these systems have covered the ocean and atmospheres, and they are quite reliable in terms of quality. But in the Arctic, as I entered into Arctic research in the 7-8 years ago, I could not rely on these equipment because I often heard that my data was not quite reliable. Why not? Because, of course, real-time observation data is very little. Traveling up north, for both land and ocean, it is difficult to maintain the equipment in harsh cold weathers, and in the ocean, of course, underwater, it is even more difficult to maintain them. So if the ocean starts to freeze, real-time data that we get will be reduced dramatically. Argo flows, Argo plots, or other very long-term monitoring system is already there in the mid-latitude areas, but in the polar areas, a global network is very lacking. And in the Arctics, well, each researchers are gathering their individual data, but what more work needs to be done is ocean data, real-time ocean data. As I predict the climate, the Arctic data, there's a huge gap in the data from the Arctic. So what's most important for Arctic climate research is to have a very tight network that covers the entire world, but in remote areas and mountain areas and the two polar regions, we have a huge data gap. So this gap can be filled. We need to build a real-time observation network in the polar region. So this is really the big wish that we have for climate researchers, but it is not easy because the observation researchers are doing very hard work, and they want to place priority in their own work and in publishing their own papers. But modeling experts need data quickly to be provided so that they can put them into their system and run the modeling and to write out the prediction. The reason why I started observation myself is because in climate research in the Arctic, before analysis, if I do not observe the data myself, I cannot get them anywhere else. I was a modeling expert, but as I moved to the Arctic, I started observation work as well. And what I want is for real time, at least for the physical data. And for this real-time physical data, we need a global network that tightly covers the entire Earth. And I want to make progress on this front to enhance predictability and to reduce the uncertainties that arise in the Arctic. Thank you.
Dr. Lee? It was great to overview the projects of COPRI. Of course, for us, we are all a part of COPRI, but we're focused on our research topics, and we do not have a lot of opportunities to look into other projects, and I can see that it betters our understanding, and I can also see the areas where cooperation may be possible. And as was mentioned, integration will be important, and I think that maybe we can have joint workshops where communication exists amongst these research projects, and if we get closer together, I think that integrative topics can emerge. And Professor Wu also talked about the importance of investment in infrastructure. Thank you very much for that comment. We are not offered with a lot of support and help from the authorities. So what happens is all of the networking communications, all of the calculations, all of the remittances, it's all done by the researchers. But I hope that as the stations receive support from the authority, it would be great if of our nodes can also get that support, then we can focus more on the research itself. Monitoring is about long-term. It's a long-term task, but in the Kiruna station in Sweden, the Kiruna station, what they do, they have a track record of temperature monitoring for 100 years. Of course, measuring the temperature is something that an elementary school student can do, but if you do that for more than 100 years, it gives you the story of what kind of climate changes exist. So I was quite envious. And in Yersin, where Tasan Station exists, in the case of the German station, for 30 years, they had balloons up in the air to check the concentration in the atmosphere. But the Tasan Research Station, we're soon enough going to meet our 20th anniversary, but we really do not have any flagship data that trends for 20 years. The reason is because the research topics, there's a churning of the topics where sustainability is not something that is guaranteed in the process. However, in the future, I hope that we can continue on to sustain our monitoring efforts. I hope that the government also opens up this chance to have these projects long term. Thank you.
Thank you all professors for your great comments. And as you have mentioned, for a long period of time, this question has been on our minds, and I want to make efforts. And I think that we need to work on finding their answers to these long-held questions. Although my project has just begun this year, I think that the projects presented today have laid good groundwork for not only relevant research, but through cooperation at home and abroad. As you mentioned, I think that we need to work on finding the right and effective and useful information to answer these long-held questions. And as Dr. Seol has mentioned, you asked for cooperation with other project leaders presented today. And I thank you for that suggestion, not only for exchanging information on microorganism studies, but climate change monitoring, modeling, and analyzing climate factors require cooperation with other researchers. So within COPRI, we have a multitude of projects, so I would love to cooperate with other project leaders and all the presenters today. Thank you very much.
Thank you, panelists, for your insightful comments. Professor Wu has also mentioned, especially in the northern Greenland, the geological research capabilities, both the potential and its link with resources, and of course, it can open up various areas of study. But when we do access this region, as was mentioned by Dr. Lee, there are the infrastructure issues that makes it difficult. If, let's say, we have a helicopter, our scope of research and our fields of research, of course, will expand and can expand immensely. And this is an unexplored area, and we do not have a station. But regardless, whenever I introduce you to the region, to the audience, many researchers showed interest. And I also saw many experts looking into the possibilities of further research. So I think that the Sejong Station and the Jangbogo Station, when we selected that particular location, we thought that this was the. I think that it wasn't based on it being an optimal location. It wasn't that. It was about the realistic challenges on the site, and based on that, that location was selected, and the researchers had to make the best out of that location, and they're engaging in their relative research. Northern Greenland, as mentioned, was uncharted land. However, Europe and the U.S., the researchers were focused on glacier research, but now they finally started to shed light on northern Greenland. In the case of next year, Denmark, Switzerland, and U.S. researchers are going to charter a helicopter, and they're going to engage in a cross-section tour of Greenland and engage in research. And I'm talking about the importance of infrastructure support. In the case of the Jangbogo Station, the chartering in helicopter And to bring that to the station, of course, the infrastructure, the research infrastructure funding offers that support, and the researchers only pay by the hour they use the helicopter. I hope that the northern Greenland, if we can find a way to be supportive with renting or chartering a helicopter, we will be able to go into areas or areas that no research was done up till now, so we can be at the forefront in such research. So it'd be great to have such support and infrastructure.
Thank you very much. I would like to thank all presenters for great presentations and discussants for your insights. 10 years ago, I actually conducted Arctic research, although on a different front. I think that in the past decade, we have seen a decade of unprecedented cooperation, and we often heard the word change, crisis, emergency, confrontation, tension. Despite this being an age of cooperation, those words kept ringing in my mind. In the next 10, 20 years, international politics and geopolitics will experience dramatic change that may affect the way forward for Korean Arctic research, and it may not be an easy road ahead. How can we make this basic scientific research to be untangled from geopolitical complications, and how we can forge ahead with our research? I think finding the answer to this question would be left to someone like myself. And I think that it was a very meaningful discussion, and I do see some remaining tasks policy-wise, and also how good we can make use of this data that we've accumulated, and we need to think deeply on how we can do this. And for the spaces of public research being done, how can it impact our Korean Arctic research? So we all need to gather our wisdom to find the right answer. And personally, Dr. Lee's task was quite welcome. I had a close friend who passed away in June. He was a researcher in mammoths, and Gazats is home to the largest burials of mammoths, and he died but he passed away, but he engaged in more than 40 years of mammoth research, and he suddenly passed away. 3 months before that, I interviewed him. I visited him in Russia, and he said he found that he found hundreds of mammoths and researched into the bone, but he found new pathogen and germs that new germs, and he is conducting research, and he was going to publish the results in a paper as soon as the research is done. But 3 months later, he passed away. So I was very shocked, and I think your area of research, Dr. Lee, can be quite dangerous. Although I cannot clearly say whether the germs actually was linked to the death of this doctor. So my words of encouragement to you, Dr. Lee. Thank you to all presenters and discussants. I hope this was a fruitful time, and I hope that we can all pool our wisdoms to find the answer to the questions that remain. Thank you very much. Thank you. I think that we were able to find the current status and the future prospects for Korean Arctic research. I hope this was a fruitful time for you. Thank you all for joining us throughout the 3 hours. And with that, we would like to conclude the seminar. Thank you. 식사가 어떻게 되는지 모르겠다. 물어봐야 돼.
And a luncheon will be prepared for the participants at